Okay, so we said switching, right? Okay, let me get me the new pen. A bigger one. So we said switching. It may be either the circuit switch, okay, or the packet switch, right? And first you tell me that I said multiplexing. I said when we say multiplexing, we discussed with that now. Now tell me. Yes, multiplexing is of. I'm not hearing.
Analog and digital.
Okay, who will tell me what is the two types in analog? What is FDM? Yes, frequency division multiplexing, and then wavelength division multiplexing. Where is wavelength multiplexing being done? Optical fiber. Okay, combining on the frequencies, and then we have done all those things. And basically, we are trying to go here. In the digital, we have spread spectrum. Okay, and in TDM, we have two things. Okay, what is the difference between synchronous and asynchronous? Because we had circuit switching and this and all. What is the difference between synchronous versus asynchronous? Yes, we have synchronous. What is happening in synchronous? जी बात है.
इसमें फिक्स्ड स्लॉट्स होगा फिक्स्ड करना है ए बी सी डी अगर ऐसे तो वोल्टेज में ये तो पैटर्न जो मतलब होगा फिक्स्ड डेडिकेटेड.
Okay, so if we have, for example, he's saying ABCD, we have, and we let it go to the, like this is my switch. What is that switch? Synchronous TDM. Okay, then I am having a fixed slots. So this slot is what he is saying dedicated to the A, this slot dedicated to B, this is the C, and this is also dedicated to the D. And it's a frame, and then we have another frame and all, right? And basically to differentiate between the frames, we have first bit either 0 or 1, then 0, then 1, alternately 0, 1, 0, 1. So this is called control bit for frame synchronization. We have already read all these things, and now you still can't. You tell me, Mukhtar, what is happening?
So start with an end bit.
किसमें?
Start में start का board and बताएगा सभी problem.
Okay. What is basic idea?
Dynamically slots that.
कहाँ से dynamically? नहीं, idea क्या है कि slots are fixed. So why is this? Why, the idea is of simplicity, and this is what is called a circuit switch. This is why we use the circuit in circuit switch. We already how many switches we read in circuit switch? What is the first circuit switch? पहला कौन सा था? Crossbar switch. The first one was a crossbar switch. Second one, space division switch. Why we use a space division? Cross points were many. Yes, in the crossbar there was a quadratic, because if the input is were say n, then the cross points we used were n square. So that was quadratic, and after also another problem was there. What was that? Yes, inputs. The basic problem was inputs, because you can build those cross points no matter how many they are. We already seen that we're using a formula, because जो मेरे cross points मैंने आपने को बताए जो थे, because it will be like a checkerboard, right? So n inputs and outputs, right? And here the cross point number of cross points will be n square, but we don't need all the n square cross points, because if we have full duplex and no self connections, then we need only the diagonal, right? We have discussed all these things, no? And the number of cross points in that case will be exactly n into n minus 1 slash 2. And we have calculated for if we have 1000 cross points, how many will be that? Right? That is 49 something. Yes, 89. 89? Will that be 89? Because this will be 1000 minus 1 is 99. Yes. 89 will not, it will be 4. 489. Because, yes. Right? Getting me? Whatever it is, it's a crossbar, or you then developed a space, जो हमने किया, space division switch हमने किया फिर, which has broken the crossbars into the many crossbars. Right? Is that? Okay, that reduced also the cross points. That also reduced what? That also reduced the inputs, right? So, but later on we said that we have also the time division switch, right? In which we have the time slot exchanger, and that reshuffles the things and then goes on, and that uses basically the TDM, time multiplexing. So, in general, we say we have a space division switch, right? Or in general, we say that the circuit switching is using the TDM, but synchronous time division multiplex. So multiplexing जो इसमें होगी, that will be synchronous time multiplexing, which has a fixed slot, because fixed slot means like a circuit switch. You getting this idea? You mixing the two. I'm mixing now the circuit switching with my the multiplex, what I have said. Because I have a fixed slot here. This slot has to go to the A, whether you have to send or not send. That's what I said in a circuit switch. You are having a telephone, you make a circuit. Now you are saying hello or you don't say anything. You are okay. आपने कॉल की हुई है, तार जुड़ गई आपके फ्रेंड के साथ, आप बात नहीं कर रहे हो, ठीक है, क्योंकि आप लोगों को कटी हो गई है. अब बात नहीं भी कर रहे हो लेकिन तार तो जुड़ी है ना. What will that happen? Nobody can send with that circuit. That so slots will go empty. That is like that. This is A, the user A, user B, user C, user D. The idea is with every user we have a slot, fixed slot. So this means this is a user A. You send it or you don't send it. If you don't send it, it will go empty. If you send it, it will have something, right? And so this will carry on. So our frames will be like, if only C has to send, D nobody has to send, it will be all empty. If nobody has to send, it will be all empty. And if, for example, A has to only send, this will be there, and something like that. So that means all the time we will see a lot of frames going empty. But the idea is that it is very simple. We do not need any addressing because every slot is fixed to the user. The slots are fixed to the user is the basic idea. That is what is the circuit switching. In other terms, we can say this is circuit switching. So in your circuit switch, you basically use the TDM, synchronous TDM. But in packet switch, we do not use the TDM because we said that you break your data into the packets, right? You break your data into the packets. Now, if your data is not continuous, it is in a packets, right? So no need to send them in a one particular way. We can send them in a multiple ways. But in virtual circuit switch, which we discussed yesterday, what we saw there, it is a combination. Yes, is it? Good. Right? Very good. Because basically your data is packet switch, like we said, what we were discussing yesterday, ISDN. Right? What is ISDN? Integrated. Is that digital or analog? Fully or half? It's a fully digital. Right? ISDN is a fully digital network, right? And in ISDN, we said then later on that we go for the then we said narrowband ISDN, broadband ISDN, right? Narrowband ISDN is again what? That is circuit switch that will use your synchronous TDM. Narrowband ISDN, right? We had discussed in detail yesterday these things. So anyways, Similarly, we got the broadband ISDN. When we say broadband ISDN, it basically uses the technology what's called the ADM, asynchronous transfer mode, and that basically comes from the asynchronous time division multiple access. Okay, asynchronous time multiple access is what we use in the packet switch. From here we have the ADM and all, asynchronous transfer mode. And in asynchronous time multiple access, what we have is we do not tie a particular slot for a particular user, right? The slots are made, the frames are made dynamically. Who has to send will occupy the slot, right? If only A and C and has to send, for example, I will send only A and C like this, right? Then say for example A again has to send, again B has to send, for example, and so on. There will be no such thing like A for A and B. There will be no empty slots. So we have reduced this empty slots. Are you getting me? If you have empty slots, okay, and if circuit switching fails, if you have a bursty traffic, don't think circuit switching is the waste, because if you have interactive traffic, then it's not a problem. The circuit switching is better for interactive traffic. But if it's bursty, you're sending some burst of data, then you're sending nothing. So that nothing part will waste your things. So in that case, packet switching is better. But packet switching has a delay, because your packets are sent to because I said in the packet switch, what I said, the basic funda is like what? How is the switch made? We have the set of input lines and set of, and what is inside? Switching fabric. Inside the switch, we basically have the queues. Okay, the packets comes on, they sit in the queues. Then there is some processing done on that where they should go, and we'll see the couple of switches of packet switch. One is a knockout switch and one is the Batch-Urbanian. So two switches we have. We will discuss them, right? As we have seen the three switches in the circuit switch. Now likewise we have the packet switches. But basic idea is that we will have the input lines and output lines, but it's a switching fabric. In case circuit switch, there was no intelligence inside the switch. It was an automatic switching, but it's just a jumper setting. You have to connect which circuit with which circuit. That has already been, we already know that. That's a fixed funda, right? But in case of your packet switch, you do not have fixed inputs with the outputs, predefined thing. It's not there. You have to calculate the address, right? You have to calculate when the packets are sent. You have to calculate the address, and then dynamically the switch basically has to think that in which channel I have to send it. That's why we have the switching fabric. So there will be queues there. There will be some processing done there, and all the stuff. Okay. So if we have an asynchronous, because if we have asynchronous now, so we do not have fixed circuit. In the synchronous TDM, we know that this slot is for the A, this slot is for the B, this slot is for C. So we know this will go to the A channel, this will go to the B channel, this will go to C, and we know that in advance. But in asynchronous we don't know. So we need to have the addressing also with the packet. The data is coming, say for example A, it also has the address. So we have a data part and also address part. It has many more things also. ये जो बाइट्स हैं ये कहाँ से कहाँ तक है, ठीक है, ये कहाँ से कहाँ तक है, ठीक है, क्योंकि एक वेरिएशन ये भी है कि आपके जो स्लॉट्स थे यहाँ पे फिक्स्ड थे, यहाँ स्लॉट भी फिक्स्ड नहीं है. द ए कैन टेक बिगर स्लॉट्स एंड देन से फॉर एग्जाम्पल आपके पास वेरिएबल ट्रैफिक है, ए को भेजना है 128 किलोबिट्स पर सेकेंड, बी को भेजना है 64 किलोबिट्स पर सेकेंड के हिसाब से. So A will be given 2 slots, B will be given only 1 slot, and like that. Are you getting me? So that उसका जो आपका ये varying traffic है वो भी इसमें cope up करे. So इसलिए हमें बताना पड़ेगा कि A कहाँ से कहाँ तक है. So addressing में ये तो एक तो ये हो गया कि इसको कहाँ जाना है, next hop कहाँ है, इसका next stop कहाँ पे है, where will it go? This is what you are saying, CCNA and all. You will read it in detail there, how to do switching. You have to go into the switch and just the basic idea you will get it here. Getting me? So it need to have here the addressing कि इसको जाना कहाँ है? You getting me? And it also has the here कि ये कितना length है इसकी, A की कितनी length है, how much long it is, B की कितनी length है, and so on. You getting me? जो इस हफ्ते absent रहा है उसको तो आज तारे दिख रहे होंगे. But who is regular is understanding what I am saying exactly. Each a piece. You getting me? Okay. So हमारे पास addressing भी होगी and all that, and this is what is happening in the packet switching. This is in the packet switching, right? So when we say packet switching, it is basically the asynchronous TDM. Okay, and the first switch which we'll see today, because in circuit switching we saw the switch, right? Give me the quick recap of that. You tell me. हाँ, कौन था पहला? In the circuit switching, make it black. In the circuit switching, why we call it circuit switching? Because circuit is main. We have the crossbar switch, right? Similarly, like we have a crossbar switch in case of circuit switch, in the packet switch, against the crossbar, we have what's called a knockout switch. What is that? And your tournaments, like in knockout tournaments, don't you have knockout tournaments like quarterfinals, then semi-finals, then finals, and all? It is based on that because it eliminates more. If you have, we'll understand what I'm saying, because we have more than what our switch can handle. More cells are coming than our switch can handle. It will remove them in the knockout fashion. So what we have is basically is like this. We have input lines. Say for example we have 8 input lines: 0, 1, 2, 3, 4, 5, 6, and 7 input lines, and they're combined with the bus. This is the broadcast bus. Mumin, what's the difference between broadcast and multicast? And if we don't have broadcast, then what we have?
ब्रॉडकास्ट में हम सब
जोर से बोलेंगे थोड़ा सा.
ब्रॉडकास्ट में हम सभी को भेजते हैं.
Okay.
मल्टीकास्ट में पर्टिकुलर.
Yes. In multicast we send broadcast and everybody will send, but in multicast we send to the group, not to all but a group. Okay. And if we don't have broadcast, then what we have? Point to point, right? So this is the bus. It's a broadcast bus. Okay. That it can go broadcast means it will go to the everyone. Then we have the output lines. But before output lines, we have that to build the switching fabric. This is the simplest one, the knockout, and this is again like we have the crossbar. Same, we have the same stuff. This bus stuff is like a crossbars and cross points, and that's why it has a disadvantage of quadratic growth of the cross points with the increase in the inputs, isn't it? In there we had the n cross n, right? The cross points. Similar situation is here also. Now what happens here is that we have the concentrator. This is the heart of it, which is called as a knockout. That's why we call it a knockout. We have a concentrator, right? थोड़ा सा इसको ठीक से बनाएंगे. This is our concentrator, right? ये उतना ठीक से भी नहीं बना. and it is combining with everyone. Getting me? अब तो जगह कम पड़ गई है, थोड़ा सा बड़ा बनाएंगे इसका. Okay, this concentrator is the knockout type. It is a concentrator. Because listen, we have a cycles in a switch. In a one cycle, okay, because we have broadcast bus, everybody would like, maybe for example we have eight input lines, maybe all the 8 input lines want to go to the first output line, right? So they will all come here. Everybody has a connection. There are cross points who combine them with here with this concept. But what we have a concentrator selects here, not all, because it depends upon what is your buffer size. Okay, what do you have? First, if you have 1000 inputs, then we need to have 1000 buffers, because if everybody, all inputs are coming into the only single input output, sorry, ठीक है, सारे इनपुट जो है ना वो जीरो के ऊपर जाना चाहते हैं, जीरो लाइन के साथ बाहर जाना चाहते हैं, ठीक है. एवरीबडी वांट टू गो टू द जीरो लाइन. दिस विल बी वेरी रेयर, दिस विल नॉट हैपन ऑलवेज, बट मे बी इफ दे वांट टू कम देन वी नीड 1000 buffers. But we know that everybody will not come, everybody from all simultaneously in a single cycle. They will not all come to where? To here, right? You getting what I'm saying? That everybody will not come here, the first output line. So therefore we do not have the, if we have 8 input lines, we will not have the 8 buffers. We'll keep some n buffers. Okay, so if you have 1000 inputs, we will not keep 1000 buffers, because we know at a time everybody is not going to go in a simultaneously through the same output line. ठीक है, सारे के सारे एक ही साइकिल में वहां जाना नहीं चाहेंगे, ठीक है. इसलिए हम उतने, क्योंकि बिकॉज जितने हम बफर्स रखेंगे ज्यादा उतना हमारा कॉस्ट बढ़ जाएगा स्विच का, एंड बिकम्स हेवी. इसलिए हम कुछ ही बफर रखते हैं, ठीक है. सो what we do is we keep here our buffers. We have the buffers, और हमारे पास एक शिफ्टर होता है. मान लीजिए 4 बफर मैंने रखे, कितने? एक शिफ्टर हमारा होता है कि जो डिसाइड करता है कि कहाँ जो आ रहा है किस बफर में रखूंगा मैं. और हम बफर का एक क्यू नहीं बनाते, मल्टीपल क्यूज रखते हैं. पहले तो हमने एक ही क्यू रखी, ठीक है, बाद में हमने कहा नहीं हमें मल्टीपल क्यूज चाहिए. सो वी सेड वी मेक ए मल्टीपल क्यूज इन हियर. सो दिस इज माय नहीं, मैं उल्टा क्यों बना रहा हूं, इसको सीधी बनाना आप, ठीक है. एंड नाउ out of them somebody will go to the zero output. So this is your output, right? Getting me? ये आपका वो स्विचिंग फैब्रिक है, और ये आपके इनपुट्स आ रहे हैं यहां से, ठीक है. And outputs going, inputs are coming to the switch. These are inputs which are coming, right? You getting me? These are inputs which are coming. This is second input coming, this is third input coming, this is fourth input coming, 5, 6 and 7, and then something happens here, and then it will go to the output 0. Similarly we will have output 1. Similarly, we will have, for example, output 1, output 2, output 3, 4, 5, 6 and 7. The same way you will develop design this thing with everywhere here, okay, with the concentrator, with the shifter and the buffers. This is my shifter and these are the buffers. Draw properly with everybody, with every output. Before output everybody will have same structure, right? ऐसा ही होगा बिल्कुल.
Sir, shifter क्या
Yes,
होता है?
I will tell you. Let me. बात समझ आ रही है मैं क्या बोल रहा हूँ? इन सब आउटपुट के साथ ऐसे ही जैसे ये हमने किया ना, इसी तरीके से करना है. ठीक है
Concentrator एक ही बनना है?
जी हाँ. कंसंट्रेटर यहाँ बनाओगे आप इसके लिए, फिर अपना इसको ये शिफ्टर, फिर इसका बफर्स, ये बफर क्यू और लगेगा इसके 1 के साथ, ऐसे जैसे 0 के साथ लगा. इसी तरीके से 2, 3, 4 सब के साथ ऐसे ही होगा. ये आप बनाएंगे नॉकआउट स्विच. यू गेटिंग मी कैसे बनाना है? तो व्हाट विल हैपन हियर इज दैट हो सकता है कि हमारे पास तो 4 की कैपेसिटी अब है, ठीक है, हमने 4 की कैपेसिटी रखी हुई है, लेकिन हो सकता है 5 या 6 आ गए हमारे पास. सो दे विल बी नॉकड आउट. ये जो आपका कंसंट्रेटर है ये नॉकआउट करेगा उनको, जो एक्स्ट्रा आपके पास है, जो आपका स्विच हैंडल नहीं कर सकता, क्योंकि हमारे पास यहाँ पे स्विच के जो हैंडल कर सकता है 1 साइकिल दैट इज 4, बट वी आर कमिंग लाइक 6 और 7, दे विल बी डिस्कार्डेड, रेस्ट विल बी डिस्कार्डेड. इनमें से कौन लगेगा कौन नहीं करेगा, दैट विल डिपेंड अपॉन यूर लाइक ए नॉकआउट, लाइक वी हैव नॉकआउट टूर्नामेंट्स, इज इट. आपने हारा तो आप डिपेंडिंग ऑन दैट क्वार्टर फाइनल होता है, फिर सेमीफाइनल होता है, फिर इन दोनों के आपस में लगता है कंपटीशन एंड सो ऑन. इसी तरीके से काम करेगा. ओके अब बेसिक स्ट्रक्चर हम बना रहे हैं और इसका जो यहाँ पे शिफ्टर है, द शिफ्टर विल डू दैट. अब हमारे पास इसने तो 4 ही पकड़ लिए, आ तो रहे हैं सब, लेकिन आधों को नॉकआउट कर लिया, आधे रख लिए. नाउ वी हैव द those guys which my switch can handle, say 4. Those 4 need to be put in the queue, right, in a particular cycle, and this is a shifter which यहां से आके इसको शिफ्ट करेगा कि भैया किस क्यू में रखूंगा मैं. इट विल डिसाइड कि मैं इनको किस क्यू में रखूंगा, right, and then there will be a token to the every queue which queue will go to the 0. ठीक है. अब पैकेट्स आ रहे हैं, एक साइकिल में आधे आ गए, दूसरे साइकिल में और आ गए, दे विल स्टार्ट पाइलिंग हियर इन ए क्यू. ठीक है, बात समझ आ रही है. सो क्यू पाइल हो रही है और वो बन रहे हैं, और फिर दे विल गो विद अनदर साइकिल, दे विल गो आउट. आर यू गेटिंग व्हाट आई एम सेइंग और नॉट? सो जिसके पास इसको जाना होगा, बट इट डिपेंड्स कि आपको कहां जाना है. ठीक है, that will be also calculated, because I told you in a packet switching we have the addressing also, so that will tell us from which cross point you have to pass on. Okay, but again there is a problem, right, that which cross point about these cross points, because if we have n inputs we need to have n square cross points. It's quadratic, so that will be huge. If we have 1,000 inputs, it will be 1,000 with 1,000 cross points, are huge. So to mitigate this problem, as we did in our crossbar switch, circuit switch crossbar, उसमें क्या बनाया था हमने? Space division. And here what we have is what's called the Batcher-Banyan. What we have is what? The Batcher-Banyan switch. That will be the last thing we'll read in this switching. That is the Batcher-Banyan switch. Okay, the switch is like the wiring is like the root of a banyan tree. That's why we call it the banyan switch. And why Batcher? Because before the banyan we have a Batcher switch. It's a combination of two switches actually. So we have a banyan switch And to fix some problems, we'll discuss what is the problem in the banyan. To fix some problems in a banyan, we have upfront badger to make it a badger banyan. So to understand badger banyan, we'll first design a banyan switch, and then we move on to the badger, because the badger basically is a switch upfront to mitigate the problems in a banyan switch. Right? First we understand what is the banyan switch and what are the problems in it. That will be the end of today lecture. So in a banyan switch, for example, we got 8 cross 8 banyan switch. 8 cross 8. We'll make a banyan, not badger banyan. Huh? First banyan, then badger. So we have 8 cross 8 switch, for example. Okay, if we have 8 input lines, at the stages we need is log to the base 2n. So n is here 8. So log to the base 2 8, that is equal to 3. So we have 3 stages. We need to have 3 stages. So accordingly, if you have how many n's you have, that many stages. So we have 3 stages like we have seen in the space division switch, but there the story was different. There was n and k, right? The cross were n and k, but here we have, this is like a 8 cross 8. So for example, we have the first set like here 1, I'm putting 4, because every banyan switch will take 2 inputs. So if I'm having 8 inputs, I need 4, right? So it will be 4 cross 4, but it will give me the inputs versus outputs 8 cross 8. Okay, this is my, for example, inputs here. 0, 1, 2, 3, 4, 5, 6, and 7. So 8 inputs. Okay. What we do is what has happened right? It's gone. Incredible, huh?